Hello and welcome to Scholarph Edu. This is our UTME prep series, and in this recording we are taking the chemistry 2011, the type B. Alright, before we begin, it is worth mentioning that in this recording we are going to be providing relatively detailed explanation. So while some questions will require analysis and detailed explanation, some are just straight up, they're just like filling in the blank. Time again is something that you don't have in abundance in this UTME exam, and that's why you need to learn to save time and be time conscious. And so we're going to be using some techniques in our solution that would help to save time. You do not have enough, like I said, time is of the essence, and so you need to learn how to calculate without using calculator. All right, without relying so much on the calculator, because punching the calculator takes some time off. So by learning some technique and some methods and stuffs, you can really calculate, and you can do sums without using your calculator. We also be providing extra notes. So on now this extra notes, some of them we might not be going through them. All right, we might not be going through them because of time, and so you may have to pause the video at some point and just read up those extra notes. And finally, you also be learning how to correctly interpret questions and answer them. And interpreting questions correctly and analyzing them in the right way is like the first step to answering that question correctly. All right, so the first question is on the paper type that you're given. Which question paper type of chemistry is given to you? A type A, B type B, C type C, and D type D. All right, this question is very important as it determines how your exam will be marked. If you pick the wrong paper type, then that means that your answers will be marked with answers that are meant for another question paper type, and so that will really affect your results. And sometimes this paper type could be letters in A, B, C, D. Sometimes it could be colors like red, yellow, green, and sometimes it could be an array of anything that's basically related. All right, so for this recording we're using the type B. That's B. All right, next is a question on acid, base, and salt. What is the concentration of a solution containing 2 grams of sodium hydroxide in 100 cm³ of solution? A 0.40 mole per dm³, B 0.5 mole per dm³, C 0.05 mole per dm³, and D 0.30 mole per dm³. Alright, so the given mass of the sodium hydroxide here is 2 grams, and the volume is 100 cm³. Now, if you look at the options that we have, there are in per dm³, and so you need to convert this 100 cm³ that we're given here to dm³, and that is done by dividing by 1000. So 100 divided by 1000 is 0.01 dm³. Alright, now the number of moles of a substance N is equal to the constitution of that substance times the volume. So you have N is equal to CV, and your C constitution is equal to number of moles divided by volume. That's when you divide both sides here by V. Now the number of moles is what we don't have yet. All right, we do have the volume, and we're looking for the concentration. Now to get the number of moles, then you see your number of mole N is equal to the given mass over the molar mass. The given mass here is this 2 gram. Then next is we calculate the molar mass of sodium hydroxide. So that's just the sum of the mass of the sodium plus the hydrogen plus the oxygen plus the hydrogen in that makes up that sodium hydroxide. Sodium is 23 plus oxygen 16, hydrogen 1, and that is 40 grams. So the number of moles N is equal to the given mass, which is 2 from the question, all right, divided by the molar mass, which you've calculated here as 40. So you have 2 over 40 equals 0.05. And so the concentration now, going back here, your concentration is equal to N over V. The number of moles divided by the volume will be equal to the number of moles, which is 0.05 divided by 0.01. And so you have C to be equal to 0.5 mole per dm³, and that is option B. Alright, next is a question on kinetic and the kinetic property of matter. Which of the following is not peculiar to matter? A. Kinetic energy of particles increases from solid to gas. B. Random motion of particles increases from liquid to gas. C. Orderliness of particles increases from gas to liquid. And D. Random motion of particles increases from gas to solid. Alright, here we have a diagram. The first one is showing the particles of a solid. Next is those of a liquid, and the last one here is that of those of the gas. Now, if you look at the way they are packed, you can tell that randomness increases, all right, from solid to gas. So A is peculiar is correct, all right. It increases from solid to gas. B from liquid to gas, that's also correct. C, orderliness increases from gas to liquid. That is when you go backward like this. So the particles that they are more, there's more orderliness here than in this. While D is not peculiar to matter, that randomness increases from gas to solid. It is the reverse case. All right, randomness increases from solid to gas, not from gas to solid. Next is on separation technique. The principle of column chromatography is based on the ability of the constituent to A, move at different speeds in the column, B, dissolve in each other in the column, C, react with solvents in the column, and D, react with each other in the column. Alright, chromatography basically is used to separate constituents of a liquid in terms of their color, like different colored constituents of a liquid. And the principle is based on the variation in the speed with which those constituent particles move along the column of the chromatographic paper. That's option A. Next is on matter and the kinetic theory of matter. From the diagram above, an ideal gas can be represented by A, M, B, N, C, K, and D, L. Alright, in that diagram, N, that's option B, represents an ideal gas. Next is a question on periodic table and electronic configuration. Which of the following is correct about the periodic table? A, the non-metallic properties of the elements tend to decrease across each period, and B, the valence electrons of the elements increases progressively across the period. C, elements in the same group have the same number of electron shell, and D, elements in the same period have the same number of valence electrons. Alright, so as you go from group 1 to group 8, the non-metallic property is increasing. You're going from metals to metalloid and then non-metals. And so A is out of it. Option C, elements in the same group have the same number of electron shells. This is also wrong. Alright, elements in the same period have the same number of electron shells, meaning the number of shells that an atom has is what determines its period. Elements in the same period, they have the same number of shells. And as for option D, the elements in the same period have the same number of valence electrons. This is also wrong. It is elements in the same group that have the same number of valence electrons. So it is the number of valence electrons that determines the group, while the number of shell determines the period. And so option B here is the correct option. That valence electrons of the valence electrons of the element increases across the period. When you go across the period, you're moving from group 1 to group 2 to group 3, and as you're going, the valence electron is increasing. Like we said, the valence electron is what determines the group to which an element belongs. So group 1, they have 1 valence electron. Group 2, they have 2. And so as you move across the period from 1 to 8, the valence electron is increasing, and that makes option B the correct option. Alright, next is a question on atoms, elements, and compound. The relative atomic mass of a naturally occurring lithium consisting 90% 7 lithium and 10% 6 lithium is, you have A 6.9, B 7.1, C 6.2, and D 6.8. Alright, so what we have here are the isotopes of lithium. Alright, 90% 7 lithium and 6 lithium. The isotopes of lithium. Now, if you're given an isotope A, if an element which is an element A which is isotopic, if its composition is given as, say, P% of XA and Q% of ZA, then the relative atomic mass of that element A is going to be P% of X, alright, plus Q% of Z. So what we're going to be doing here is we have 90% of 7Li. So you're going to have 90% of that 7 plus 10% of 6Li. That's 10% of 6. So 90% of course is 90 over 100, and that is 0.9. 10% is 10 over 100, that is 0.1. So you have 0.9 times 7, 6.3 plus 0.1 times 6, and that is 0.6. This plus this is 6.9, and that is option A. Next is also on atom, element, and compound. An isotope has an atomic number of 15 and a mass number of 31. The number of protons it contains is A 16, B 18, C 46, and D 31. Alright, so isotopes, they are atoms of elements that have the same atomic number but different atomic masses. And of course, the atomic number is the number of proton in the nucleus of the atom. And so the atomic number of this isotope is given as 15. The number of proton is thus 15. Alright, The atomic number is also called the proton number. That is the number of proton in the nucleus. In isotopes, what varies basically is the number of neutrons that you have. So the atomic number is 15, and so that is the number of protons. Next is on chemical combination and bonding. The molecular lattice of iodine is held together by A, dative bond, B, metallic bond, C, hydrogen bond, and D, van der Waals force. Alright, so this is a question on intermolecular forces or bond. The molecular lattice of the molecular lattice of iodine, they are held by weak van der Waals force. That is option D, weak van der Waals forces. Next is related to nuclear chemistry. The arrangement of particles in crystal lattice can be studied using A, X-ray, B, gamma rays, C, alpha rays, and D, beta rays. Alright, the arrangement of particles in crystal lattices is studied or can be studied using X-rays. Alright, the gamma ray, the alpha ray, and the beta ray, they are radioactive radiations. Alright, this is a question on solubility. From the diagram above, find the amount of solute deposited when 200 cm cube of the solution is cooled from 55 degrees Celsius to 40 degrees Celsius. We have A 0.10 mole, B 0.20 mole, C 0.01 mole, and D 0.02 mole. Alright, so this is a graph of solubility against temperature. Now the volume of the solution is given as 200 cm cube. We need to convert that to TM cube. Alright, and that is by dividing by 1000. So you have 200 divided by 1000, it gives you 0.2 dm cube. Next, cooling from 55 degrees Celsius to 40 degrees Celsius. That 55 degrees Celsius is like 8 here. Alright, if you choose it down to this, so it's like that's 8 mole per dm cube. Alright, and 40 degrees Celsius, that is 6.8 mole per dm cube. Something here, not up to, this is 6 and then 8, so it is not even up to 7. That's like 6.8 mole per dm cube. Difference in solubility is thus 1.2 mole per dm cube. Now the number of moles of that solute that will be deposited between, if it's cooled, if this solution cooled from 55 degrees Celsius to 40 degrees Celsius, will be equal to the difference in solubility, which is 1.2 times the volume of that solution, and that is 0.2 dm cube. So you have 1.2 times 0.2 dm cube, and that will give you 0.2 mole approximately. This is actually 0.24 approximately. That is 0.2 mole. That's option B. Alright, this is a question on water. The importance of sodium aluminate in the treatment of water is to A, cause coagulation, B, neutralize acidity, C, prevent goiter and tooth decay, and D, kill germs. Alright, so chemicals like your potash alum and sodium aluminate, they are used to cause coagulation. That's option A. And coagulation is a process where big giant weight particles are made to aggregate together, to clump together, and those particles are deposited. As for prevention of goiter and tooth decay, then for tooth decay you have fluorine, and for goiter you have iodine. To kill germs you have chlorine. Chlorine could be added to the water to kill germs. So basically this is a question relating to the supply of water. Alright, so iodine is added to prevent goiter, tooth decay, that is fluorine, and then for killing the germs you have the chlorine. And calcium oxide can be used to neutralize acidity. Coagulation, you have sodium aluminate and potash alum. Next is a question on atoms, elements, and compounds. Also relates to chemical bonding. What type of bond exists between an element X with atomic number 12 and Y with atomic number of 17? With atomic number 17. A, electrovalent, B, metallic, C, covalent, and D, dative. Alright, so the element X here with the atomic number of 12, alright, that is your magnesium, while that with the atomic number of 17 is chlorine. Now the bond between that will be formed between, of course, the magnesium and chlorine will be your MgCl2, which is an ionic bond. Alright, that's electrovalent, ionic or electrovalent bond, option A. This is another question on water. Hardness of water is mainly due to the presence of A. Calcium hydroxide or magnesium hydroxide, B. Calcium thiazocarbonate or calcium tetraoxosulfate, C. Sodium hydroxide or magnesium hydroxide, and D. Calcium chloride or sodium chloride salts. Alright, so the hardness of water is due to the presence of calcium and magnesium ion in the form of bicarbonate or in the form of tetraoxosulfate. And so option B is the correct option here. The bicarbonate is, of course, in temporary hardness of water, while tetraoxosulfate is in the permanent hardness of water. Next is a question on solubility and organic chemistry. A suitable solvent for iodine and naphthalene is A. Carbon sulfide, B. Ethanol, C. Water, and D. Benzene. Iodine and naphthalene can be dissolved in ethanol. Alright, iodine solution is formed by dissolving iodine in ethanol. That solution is used in treating wounds and injuries, like superficial injury. Option B. Next is on air. Which of the following noble gases is commonly found in the atmosphere? A. Xenon, B. Neon, C. Helium, and D. Argon. Alright, argon is the most abundant noble gas in the atmosphere. That's option D. Next is a question in chemical equilibria. In the reaction above, an increase in temperature will A. increase the value of the equilibrium constant, B. decrease the value of the equilibrium constant, C. increase the reactant production, D. shift the equilibrium to the left. Alright, if we look at this reaction here, we can see that it is endothermic since your delta H is positive. For isothermic reaction, it is negative. Now, in an endothermic reaction, alright, where it is absorbed from the environment, now increasing the temperature is going to favor the forward reaction, alright. And every reaction where the forward reaction is favored, the equilibrium constant will increase. Where the backward reaction is favored, the equilibrium constant is going to decrease. So option A is the correct option here. Increasing the temperature is going to favor the forward reaction in an endothermic reaction like this, alright, and that would consequentially increase the value of the equilibrium constant. Next is a question on organic chemistry. In the reaction above, CH3COO- is A. the conjugate base, B. an acid, C. base, and D. conjugate acid. Alright, so this CH3COO- is from the acid. Alright, and acid, they form the conjugate base, and so CH3COO- is the conjugate base. That is option A. Next is related to atoms, element and compound, and electrochemistry. How many cations will be produced from a solution of potassium, aluminium tetraoxosulfate? 6. A3, B4, C1, and D2. Alright, so in this solution, you have two metals. Now, cations, they are positive ions that are produced by metals. And in this compound, you have two metals, that is potassium and aluminium. Alright, so each of them will form a cation. The potassium will form one cation as K+, the aluminum will form another as Al3+. And so the sum of the cations that we have is 2, that of the potassium and aluminium. That's option D. Next is an acid, base, and salt. Which of the following is not an alkali? A. ammonia, B. magnesium hydroxide, C. calcium hydroxide, and D. sodium hydroxide. Yes, I guess you can easily tell here. The odd one out here is ammonia. Now, an alkali is a soluble hydroxide. Ammonia is a base, but not an alkali. So all alkali are bases, but not all bases are alkali. Option A. Next, an effect of thermal pollution on water bodies is that the A. volume of water reduces, B. volume of acid waste increases, C. level of oxides of nitrogen increases, and D. level of oxygen reduces. Thermal pollution of water bodies is going to lead to an increase in the rate of evaporation of the water, and it would also reduce the level of oxygen. Option D. Which of the following is a delinquent substance or compound? This is a question on substances. A. sodium thiazocarbonate, B. calcium chloride, C. copper oxide, and D, sodium carbonate decahydrate. Alright, so the liquid substances, they are also called desiccants. They are substances that have high affinity for water. They absorb water from the atmosphere and they form a solution with that water. Examples include your sodium hydroxide, your iron chloride, your calcium chloride, which is option B from here, and that of course is the correct answer. You also have your potassium oxide, you have the silica gel, etc. Next on chemical equilibrium, a chemical reaction which the hydration energy is greater than the lattice energy is referred to as A spontaneous reaction, B, an endothermic reaction, C, an exothermic reaction, and D, a reversible reaction. A chemical reaction in which the hydration energy is greater than the lattice energy, that is an endothermic reaction. Next is on electrochemistry, the galvanic cell. The function of zinc electrode in a galvanic cell is that it A undergoes reduction, B serves as the positive electrode, C produces electrons, and D uses up electrons. Alright, the zinc rod or the zinc electrode in a galvanic cell functions as the positive electrode that loses electron, becomes oxidizes. That's option B. Next, also on organic chemistry, the major factor that include the weight that influences the weight of the reaction above is A, catalyst, B, temperature, C, concentration, and D, light. Alright, the substitution reaction between chlorine and methane is a reaction that is photochemical, meaning it is influenced by light, option D. Next is on water and air. The condition required for corrosion to take place is the presence of A, water and carbon dioxide, that's carbon dioxide, B, water, carbon dioxide, and oxygen, C, oxygen and carbon dioxide, D, water and oxygen. Alright, there are only two conditions that are required for corrosion to take place, and that is the presence of water and oxygen, option D. Alright, next is a question on thermochemistry. In the diagram above, X is the A, enthalpy, B, enthalpy change, C, activation energy, D, activated complex. Alright, so in this diagram, your X here is your enthalpy change, your delta H, which is the difference between the heat content of the product and that of the reactant. That's like the H, the heat of the product minus the heat of the reactant. Here we mean like the sum of the heat of the product minus the sum of the heat of the reactant. Another thing here that we can say about this diagram is that it is a diagram that depicts an endothermic reaction, because as you can see here, the heat of the reactant is greater than the heat of the product. All right, and that is an endothermic reaction. You see this theta H here would be positive for endothermic reaction since it is taken in. You can think of it as adding heat. Next is a question in chemical equilibrium. The diagram above illustrates the effect of decrease in A, concentration, B, temperature, C, surface area, and D, pressure. Alright, so in a chemical reaction, as the reaction proceeds, the concentration of the reactant is going to decrease with time, while that of the products will increase with time. So here you can this graph here, the curve sloping downwards here, means the rate of reaction is reducing with time, and that is due to a decrease in the concentration of the reactant with time. That's the concentration of the reactant. That's option A. The concentration of the products on the other side increases with time. Next is a question on atoms, elements, and compounds. In the diagram above, Y is A 5H plus, B 4H plus, C 10H plus, and D 8H plus. Of course, the H plus is hydrogen ion. Alright, so if you look at this equation there, alright, you realize that there's something missing on the reactant side. Alright, if you look at what we have here, you have your manganese, you have manganese here, you have iron here, you have oxygen here. Alright, but then you have hydrogen on this side, you do not have hydrogen on this side, and so this Y here must be hydrogen. So what amount of, like, how many moles of hydrogen is it? Now remember that in the chemical equation, the number of the reactants and the product side must be balanced. So if you look here, how many hydrogen do we have here? There are 8 hydrogen. That's like 4 times this 2 here. So you have 8 hydrogen. So how many hydrogen is supposed to be here? That would be 8. So that's option D. Right, next is a question on electrolysis. Given that M is the mass of a substance deposited during electrolysis and Q is the quantity of electricity consumed, then Faraday's first law can be written as where E is denoting the electrochemical equivalent here. A, M equals E over Q, B, M equals EQ, C, M equals Q over E, and D, M equals E over 2Q. Alright, so by Faraday's first of electrolysis, the mass of the substance that is deposited, this M here, is directly proportional to Q. And so turning that into an equation, you're going to have M equals Q times the constant, where that constant here is the electrochemical equivalent. Usually it is denoted by Z, but in this question you are taking it as E. So you have your M to be equal to Q times E, and that is EQ or ZQ. Of course here it is EQ, and that is option B. Next is on substances. The impurities formed during the laboratory preparation of chlorine gas are removed by A, water, B, ammonia, C, sulfuric acid, and D, hydrochloric acid. Alright, so chlorine can be prepared from reacting hydrochloric acid with manganese oxide. The impurities are removed using water. That's option A. Next is related to matter and kinetic theory of matter. The effect of the presence of impurities such as carbon and sulfur on iron is that they A, give it high tensile stress, B, make it malleable and ductile, C, increase its melting point, and D, lower its melting point. Alright, so generally the presence of impurity decreases the melting point of a substance while it increases its boiling point. So D here is correct option, that they lower its melting point. Next is on qualitative analysis and metals and their compounds. A few drops of concentrated triazonitrate acid is added to an unknown solution and boiled for a while. If this produces a brown solution, the cation presents are likely to be A, lead, B, copper ion, C, iron 3, and D, iron 2. Alright, so the ion that is present in that solution is iron 2, which is originally greenish. Its color is greenish. It becomes brown due to oxidation to iron 3. So the original ion that is present, that is indicated by this brown coloration, is the iron 2. That is the original ion. Next is on non-metals and their compound. The bleaching action of chlorine gas is effective due to the presence of A, hydrogen chloride, B, water, C, air, and D, oxygen. Alright, the bleaching action of chlorine is effective due to the presence of water. That is option B. So chlorine reacts with water, forming what we call hypochlorous acid, that's HClO, which generates nascent oxygen, that's unstable and a reactive monoatomic oxygen that bleaches the material. Alright, so the effectiveness, the bleaching action of the chlorine gas is effective due to the presence of the water. Next is also on non-metals and their compounds. In the laboratory preparation of oxygen, dried oxygen is usually collected over A, hydrochloric acid, B, mercury, C, calcium chloride, and D, tetraazosulfate 6 acid. Dried oxygen is collected over mercury. This one is related to acid, base, and salt. The property of concentrated tetraazosulfate acid that makes it suitable for preparing triazonitrate acid is its A, boiling point, B, density, C, oxidizing property, and D, dehydrating properties. Alright, so less volatile acids like your sulfuric acid, H2SO4, have a high boiling point. That's option A. Now reacting a less volatile acid with a salt containing an anion for another acid is going to produce a volatile acid. For example, when you react sodium chloride with hydrogen sulfide, you're going to be having sodium sulfide and hydrogen chloride, which is a volatile acid. If you react sodium tetraoxosulfate with sodium chloride, you're going to be having hydrogen chloride and sodium tetraoxosulfate. Your hydrogen chloride is a volatile acid. Next is on metals and their compound. This relates to substances. Bronze is preferred to copper in the making of metal because it A is stronger, B can withstand low temperature, C is lighter, and D has low tensile stress. Alright, so alloys like bronze are sometimes preferred, as materials because they are more durable, they are less reactive, alright, they are passive, and they have better aesthetics or appearance. So the bronze, which is an alloy of tin and copper, is preferred to copper in the making of metal because it can withstand low temperature. Next is on substances. The constituents of baking powder that makes the dough to rise is A, sodium bicarbonate, B, sodium hydroxide, C, sodium carbonate, and D, sodium chloride. Alright, the baking powder is sodium bicarbonate, that is sodium hydrogen thiazocarbonate. It is used as a leavening agent. It causes raising in dough, and that is due to the production of carbon dioxide, which as a gas causes that dough to rise. Option A is the correct option, sodium bicarbonate. Your baking soda, that is sodium carbonate. Next on organic chemistry, which of the following compound is used as a gaseous fuel? A, you have this is an alkane, alright, with the double bond. Here you have an alkanol, next you have an alkanoic acid, and lastly you have an alkane. Alright, alkanes, they are largely used as domestic and industrial fuels. Alright, and from the option, the alkane that you have here is option D, that is butane. Next is on organic chemistry. The ability of carbon to form long chains is referred to as A, alkylation, B, acylation, C, catenation, and D, carbonation. The ability of carbon to form long chain is regarded as catenation, and that long chain is what you have in organic compounds, especially giant molecules. Next on organic chemistry, which of the following compounds will undergo polymerization reaction? A, you have an alkane, B, you have an alkanoic acid, C, you have an alkane, and D, you have an alkanol. Alright, unsaturated hydrocarbons like the alkane, here it is ethane that I have here. Unsaturated hydrocarbon like ethane would undergo polymerization. Ethane, for example, will undergo polymerization to form polyethylene. That's option A. Next is on organic chemistry. The compound above exhibits A, geometric isomerism, B, optical isomerism, C, structural isomerism, and D, positional isomerism. Alright, in this compound you have a chiral carbon atom, and so this compound would exhibit optical isomerism. A chiral carbon atom is an atom that has 4 different groups attached to it. So here, for example, you have the alkyl group attached to it, that is CH3 methyl. You have the hydroxide group attached to it. Here you have the carboxylic group attached to it, like this is of the carboxylic acid, and here you have like the regular hydrogen attached to it. Next is also on organic chemistry. An organic compound has an empirical formula CH2O and vapor density of 45. What is the molecular formula? You have A, C3H7OH, B, C2H5OH, C, C3H6O3, and D, C2H4O2. Alright, so the first thing we do is represent the molecular formula of this compound here as CH2O and N, where this N here is the factor that we're going to use to multiply to get the molecular formula, the molecular formula. Now, what is the empirical formula? It is a formula that shows the simplest ratio in which the atoms in that compound are combined. So, for example, glucose is C6H12O6. However, its empirical formula is CH2O, meaning that you have one atom of carbon with 2 of hydrogen and 1 of oxygen. The multiplicative factor here is 6. All right, that is, if you multiply this 2 by 6, you'll be having your C6H12O6, and that is glucose. So when your N is 6 here, then you have glucose. And so what we need to do in this equation and in this question as well is to find that that factor N that we're using to multiply here. Now, the molecular formula, the molecular mass, I mean, is also equal to 2 times the vapor density, and the vapor density here is given as 45, so you have 2 times 45, and that is 90. Now what we are going to do is equate, all right, the molecular mass of this compound, that is CH2O, with that N, equate it to this molecular mass here, that's 90. So then you are going to have your CH2O, you find the molar mass, all right, in bracket N equals 90. Carbon is 12, hydrogen is 1, so you have 2 of it, so you have 2 times 1, then plus oxygen, which is 16. When you add up all of this, you're going to be having 30, N equals 90. Divide both sides by 30, and your N is equal to 3. So the multiplicative factor here that we're using to multiply through here to get that molecular formula is 3. So when you multiply through, you're going to be having 3 times like 1 here, and then times 2 here, times 1 here. You have C3H6O3, and that is option C. Next, also on organic chemistry, the reaction represented by the equation above is useful in the production of A. propanol, B. butanol, C. methanol, and D. ethanol. Alright, so what we have here is glucose fermenting to produce alcohol. This is an alcohol here. Alright, this is your ethanol. So this reaction is useful in the production of an alcohol, that is ethanol. The fermentation, now the zimase here, is an enzyme, a biochemical catalyst that helps to facilitate this process. Alright, next question on organic chemistry. The number of isomers that can be obtained from butane, that's C4H10, is A3, B4, C1, and D2. Alright, butane has 2 isomers, and that is N-butane and 2-methylpropane. The N-butane is the normal butane where you have 3 or 2 hydrogen atoms only attached to the carbon atoms, while the second isomer, which is 2-methylpropane, is where you have one of the CH3 acting as, a substituent on the second carbon atom. So this is 2-methylpropane, propane because this is 1, 2, 3. All right, and this here is methane, so you have 2 because on the second carbon atom, so you have 2-methylpropane, while this is the normal butane, N-butane. Option D is the correct option. Next is also on organic chemistry. The functional group present in the compounds above are, you have A. alkane and allo group, B. hydroxyl and chloro group, C. alkane and chloro group, and D. hydroxyl and allo group. Alright, so if you look at this compound, we have 2 functional groups here. One is this OH group, alright, which is your hydroxyl group that you have in alkanos, and the second is this allo group, and the allo group is for the group of halogens, your chlorine, your fluorine, your bromine, your iodine. All right, so you have the hydroxyl group and the allo group. That's option D. All right, the hydroxyl group and the allo group. Next, which of the following is a primary amine? You have A, B, C, and D. All right, so the options are here as images. You have option A, option B, option C, and option D. Alright, the amines, they have the NH2 group. Alright, they have the NH2 functional group. Now we have the primary, secondary, and tertiary amine, depending on the number of the alkyl group that is attached to that NH2 group. Where it is 1, it is primary. Where it is 2, it is secondary. Where it is 3, it is tertiary. Now if you look here in option B, you have only one alkyl group. This is your methyl. Alright, only one alkyl group is attached to that NH2, so that makes this, a primary amine. That is option B. In option D, you have 2. All right, in option D you have 2, like 2 of this alkyl group. Why here? This is another thing entirely, and the same thing as this. So this is not even an amine because this is not NH, it is just NH. All right, so B is the correct option. You have one alkyl group attached to that amine. That's a primary amine. Option B. Next, on organic chemistry, 2 organic compounds K and L are treated with a few drops of Ferlin solutions, respectively. K forms a brick red precipitate, while L remains unaffected. The compound K is A alkanol, B alkane, C alkanol, and D alkanol. Alright, for the Ferlin solution, reducing sugar and alkanals, they produce a brick red precipitate. That is option C. The solution or reagent is used to distinguish between soluble carbohydrates and ketones. They also use it to test for reducing and non-reducing sugar. So a positive test will be the production of a brick red precipitate with reduced sugar and alkanes. Alright, next on organic chemistry, which of the following statements is true about 2-methylpropane and butane? A, they are members of the same homologous series. B, they have the same boiling point. C, they have different number of carbon atoms. And D, they have the same chemical properties. Alright, so this is related to a question that we've seen before about the number of isomers that butane forms. Butane forms 2 isomers, and that is your N-butane and your 2-methylpropane. Now, if you look at the naming here, alright, butane ends with ANE and propane with ANE as well. And this is the suffix for members of the alkane group. Alright, butane and propane, they are members of the same homologous series. And that is true of isomers of the same compound, that they belong to the same homologous series, and that's option A. Question on organic chemistry. The reaction above is best represented or described, is best described as A, esterification, B, condensation, C, saponification, and D, neutralization. Alright, so in this reaction you have an alkanoic acid reacting with an alkanol to produce an alkanoate and water. This alkanoate is also known as ester. This reaction here is esterification. Alright, the reaction between an alkanate, it's a type of condensation reaction where an alkanol reacts with an alkanoic acid producing an alkanoate, that is an ester and water. So for example, here you have ethanol reacting with ethanoic acid to produce ethyl ethanoate, which is an ester and water. Option A is correct option here, esterification. It is a type of condensation. Now this is just like, you know, some of the previous questions that we've come across. So this is a question about specific. Even though esterification is a type of condensation reaction is a reaction where simpler molecules, you know, they combine to form another molecule, and in the process a smaller molecule is eliminated, like this water that is eliminated here. In some cases it may be ammonia, it may be hydrochloride. So this is esterification is also a type, you know, an example of a condensation reaction, but more specifically this reaction here is esterification reaction. It is esterification reaction. All right, so the specifics is what you go for in questions like that, where you have a specific and a general answer. Alright, so that's it for this video. Thank you for watching. If you're new to the channel, please endeavor to subscribe and like and share our content. Also check out our playlist for crash courses on physics, chemistry, and biology. Those videos are tailored for examination candidates like you. You could use them to prepare for examinations like UTME. You can also use them for revision. You can also use them if you want to get a hold of a topic, like get an overview of a topic. All the best in your examination. Do not forget to practice free UTME at exams.scholarph.com, so you can use that to practice for your UTME exam and put yourself in the exam, you know, situation. Also, we have modular quizzes, so if you've read the topic in biology, physics, or chemistry, you can head on to exams.scholarph.com to take modular quizzes and just see how well you're doing with that topic. Thank you.